Honors Pre-Calculus, section 10.4, hyperbolas. A hyperbola is very similar to an ellipse, but instead of the sum of the sum of the distances being constant, it's the difference of the distances that are constant. So a hyperbola is the set of all points in a plane such that the difference of the distance should have been difference of the distances. I had my plurals mixed up there, sorry. Difference of the distances from two fixed points is constant. Okay, remember for an ellipse, the foci here and any point on this ellipse, P to F1 plus P to F2 is constant. For a hyperbola, which has two branches, choosing any point on this hyperbola, the focus here, there's one of them, here's another one. If we find the distance between P to F1 and the distance from P to F2 and subtract them, P to F1 minus P to F2. Now clearly P to F1 is shorter than P to F2, so we need to turn that difference in those distances positive. So the absolute value here, that's constant for each hyperbola. Visually, that's the main difference between them. Some important vocabulary and information about hyperbolae, plural for hyperbola. Okay, so we've got two axes going on here. They're not called major and minor axes. They're called the conjugate axis. And the conjugate axis goes between the two branches. The transverse axis cuts through the two branches. And where the conjugate and the transverse axis intersect, there's the center. Vertices where the transverse axis intersects the two branches. So here's a vertex. There's a vertex. And the foci are out here. Here's one focus. Here's another focus. Now remember how for an ellipse, c squared was the absolute value of a squared minus b squared? For a hyperbola, c squared is a squared plus b squared. And c, again, is the distance between the center and a focus. Distance between the center and a focus. Alright, now the general equation for a hyperbola centered at some point hk is the following. X minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. In this setup, The only difference between a hyperbola and ellipse is that sign right there. For a hyperbola, that's minus. For an ellipse, that's plus. Look up here. C squared is a squared plus b squared for a hyperbola. So these signs are different. And for an ellipse, this was a squared minus b squared. And that was plus down here. All right, let's go graph a hyperbola. Starting right here. Graph and identify the important information. Okay, center is at 1, -2. Right here, there's your center. Now, just like for an ellipse, these numbers here tell you how far to go in each direction. So we're going to go 2 in the x direction. And we're going to have to go 4 in the y direction. Okay, this is where it's very different for a hyperbola. An ellipse, you would just draw that in. For a hyperbola, you are going to create a box using these points that we had out there. So I'm going to take a ruler, and we're creating a rectangle here. You see that rectangle taking shape? And here. Once you have that, then take the ruler, and you need a ruler for this, and you are going to draw a line, diagonals, go from corner through the center to the other corner, extend that well beyond the graph, and go the other direction as well. Corner to corner, smack dab through the center, right there. This just tells you how to draw, how wide to make the branches. But this is all set up. We haven't actually drawn the hyperbola yet. Okay, now, since the x quantity came first, that tells you that the branches are going to go sideways around the x-axis, if you will. So, going this way, out toward this line, but not touching it. Out toward that diagonal line, but not touching it. Same thing on this side. While we're drawing these branches in, think about what's a line that your graph gets close to, but doesn't actually touch. Well, most of the time doesn't touch. In very few cases it can touch. An asymptote. We do have some asymptotes here. The hyperbola is the blue. My pink is just the setup to see how big to make that hyperbola. But the hyperbola itself is blue. Okay, labeling the rest of this important information up here. We have the vertices. Vertices right there and right here, so that's at 3, -2, and -1, -2. The transverse axis. The transverse axis goes through the vertices, so that is at y equals -2. The conjugate axis perpendicular to the transverse axis through the center, and that is happening at x equals 1. And the foci. Alright, the two foci. These are kind of in this curve, if you will, out here somewhere. Not exactly sure where it is. I'm just kind of estimating right now. Clearly those two foci have the same y coordinate. They both have a y coordinate of -2. To find that x coordinate, we'll have to go through c squared is a squared plus b squared for a hyperbola. So c squared is 4 plus 16. C is plus or minus 2 square root 5. Again, that's the distance from the center. So from this x coordinate of 1 plus 2 square root 5 and 1 minus 2 square root 5. All right, one last important piece of information that we need to find is the equations of the asymptotes. All right, now we can read slope and we can read y-intercept. Slope is, for this one right here, up 1, 2, 3, 4 and over 2. So y equals a 2x and the y-intercept is -4. This one, the slope is -2 and the y-intercept is 0. So just y equals a -2x. You can always read slope because slope is from the center to a corner of that box, and you know the dimensions that you created that box. Sometimes we can't see the y-intercept very nicely, and then we just go back to point slope form of a line and do some algebra manipulation. All right, let's come down here and let's look at this one. Not set up very nice. We need to do some manipulating here. Let's group our x's and y's. We have y first here, so I'm going to keep it first. Y squared minus a 2y. And then minus a 4x squared plus a 16x. And I'm going to pull that 19 over to the other side and out of the way. Completing the square here on the y's. Half of 2 is 1 squared 1, so I'll have to add 1 to this side over here. For the x's, you're going to have to factor out a -4. Be careful here, -4, which is x squared minus a 4x. Let's complete that square. Let's see, half of 4 is 2 squared 4, so plus a 4. But we really added a -16 to this left side, so minus a 16 over there. Then factoring, we'll have a y minus 1 squared minus 4 times an x minus 2 quantity squared equals a 4. Let's divide out that 4. And we have y minus 1 quantity squared over 4 minus an x minus 2 quantity squared over 1 equals 1. Now we see our center at 1, 2. No. Not 1, 2. Be very careful here. Very careful. The 2 is with the x. So your center is at 2, 1. Be very, very careful. Center is at 2, 1. There's the center. In the x direction, we're going to go 1 unit. In the y direction, we're going to go 2 units. Create that box. When you're using graph paper, you can pretty much make the box without a ruler because you could just follow the grid lines. However, when you draw in the asymptotes, you really need to use a ruler so that we can extend these lines straight and accurate. There. Now the hyperbola, the branches could either go sideways this way, one this way, this way like we did in the last one, or they could be the up and the down ones. So we look to see which quantity is first. The y's are first, which means we're going to open up and down. And my hyperbola is blue again. And this just curves out toward those asymptotes. Let's finish listing our important information. Center we already have. Vertices 2, 3, and 2, -1. Transverse axis. Goes through the vertices, that's at x equals 2. Conjugate axis. That goes this way, that's y equals 1. The foci, right up here somewhere, or down here. And for those foci, let's use c squared is a squared plus b squared. C squared is 4 plus a 1. So c is plus or minus square root 5. And in this case, the x coordinate is 2, comma something. And the y coordinate will be 1 plus square root 5 and 1 minus square root 5. If you want to, you can just list the two foci in this fashion, 2, 1 plus or minus the square root of 5. So you're showing both points there, you're just saving a bit of space. And the last bit here, asymptotes. Okay, let's do the one with the positive slope first. I can read my slope up 2 over 1. My y-intercept is at -3. And the line with the negative slope, -2, y-intercept is 5. And there we go. Okay, now I've given you some equations and you have graphed it. Let's flip it around and go the other way. I would like you to find the equation of a hyperbola with the center at 0, 0, focus is 0, 5, and vertex is 0, 3. Again, quick sketch. Center, 0, 0. Focus, 0, 5. Vertex, 0, 3. All right, right there, it's telling you that one branch goes this way and the other one has to be down here going this way. Since this is opening up and down, we know that the y quantity has to come first. So we're going to have y minus 0 squared over something minus x minus 0 squared over something equals a 1. All right, the something, distance from the center to a vertex is 3. So that means in the y direction, we went up 3, so that's got to be 9 here. X direction, we don't see a box here. We're going to have to figure out what we did. If we go back to, for this focus, c squared is a squared plus b squared. C is the distance from the center to a focus, so that's 5. A squared plus 9, it doesn't matter which one you call A and B. Let's see, so 25 minus 9, a squared is 16. Filling that right in here, and we are left with y squared over 9 minus x squared over 16 equals 1. And there we go. One last one here. Find the equation of a hyperbola with vertices 4, 0 and negative 4, 0 and asymptotes y equals 2x. Vertex 4, 0 and negative 4, 0. All right, right there, you know this hyperbola is doing this somehow. Not sure how wide it is or anything like that, but it is curving sideways, which tells us the x quantity has to be first. All right, if the vertices are at negative 4, 0 and 4, 0, then center must be at 0, 0. That's nice. X direction, we went 4 units in each direction. That means a 16 has to go here. And we need that. We do not have a focus. But we do have an asymptote y equals 2x. If I put that in here, y equals 2x, then I know that the box must have hit up here, right there. And I am looking for this distance. Well, at x is 4, has to hit this line, y equals 2x. This point right there has to be 4, 8. Which means to get the top part of this box from the center, we must have gone up 8, which means underneath here is 8 squared or 64, and our final answer is x squared over 16 minus y squared over 64 is equal to 1. And I believe that's it for this section, because the next page has been left blank intentionally. All right, please go work on your section 10.4 homework for hyperbolas. Thank you.